Let's take a look at another reaction of alcohols. In this case, we're going to make an alkene. This is also known as a dehydration reaction. And a dehydration reaction is any kind of reaction that removes a molecule of water from the compound. And so let's go ahead and take a look at this example. And so what we're going to do to this alcohol is place it in some concentrated sulfuric acid. Right, this compound right here is your sulfuric acid. However, sulfuric acid is always in water. And so if you think back to the leveling effect, our actual acid here will be H3O plus. And so the first step is going to be protonation of this alcohol. So the first step here will be a proton transfer in order to make this a good leaving group. Right, now we've made this into a water, so it's a good leaving group here. You can see it's a tertiary, so SN2 can't happen. There's no strong base here, so E2 is not going to be highly preferred. And so we can think about the E1 pathway or SN1 pathway. And so the first step in either is going to be the leaving group leaves. To form our carbocation. In this case, this is a tertiary carbocation, and so we don't need to think about rearrangements in this case. However, you might see some rearrangements occur in these types of reactions. And then at this point, right, we've still got some water molecules floating about. And so one of two things can happen. An SN1 reaction can happen, but more often it's going to be an E1 reaction occurring to form an alkene. Right, and then we have our alkene formed. These reactions can also occur with primary alcohols. However, if you think about the mechanism here, this is going to proceed through an E2 reaction because the formation of a primary carbocation is unrealistic. And so you can see how we have this different reaction, but really it's just the application of these E1, E2, SN1, SN2 type of reactions and considerations that we're thinking about.